Well, welcome everybody. Good morning, good afternoon, good evening to wherever you may be. I was wanting to welcome you to this webinar today, where we're going to be talking about how to bring agents into the real world to solve real world problems that you and I face every day. And I'm happy to be joined by our very strategic partner, NVIDIA, so we can talk about not only our partnership together, but then also some of the things that they've been doing to help make it easier for agents to be deployed and solve real problems. So today, oh, by the way, I'm Andy Center, Field CTO at VAST Data, and I'm really excited today to be joined by Adil Halak, who, well, Adil, I'll let you introduce yourself and what you do.
Yeah, good to be here. So good morning, good afternoon, good evening, everybody. Like Andy said, my name is Adil Halak. I lead product management for NVIDIA Enterprise. And so what my team does here at NVIDIA is we build microservices and blueprints that are production grade that help platforms, our partners, and enterprises ultimately be able to build and operationalize agents. And so super excited to be here and share what Andy's team and I have been up to of late.
That's awesome. Thanks for joining. And before we get started on everything, maybe you could describe when you say the word blueprint, what do you mean? What does that mean in NVIDIA?
Yeah, it's a great question, and frankly, it's a term that's utilized quite a lot these days. And so, when you think about agentic AI or any kind of AI workflow, right, it isn't just made up of a single model, right? A single model in itself is of some value, but more often than not, you need to ground that large language model with your corpus of data. More often than not, you need to guardrail the output of those models, right, for it to stay on topic. And so what blueprints are essentially are a collection of microservices that are specific to deliver a given use case, right? And retrieval augmented generation is a blueprint that we continuously augment, maintain, right, and republish. And so what they are is we take the guessing work away from a do-it-yourself approach, and we provide blueprints or recipes, if you will, or cookbooks, if you will, for how you bring all these different pieces of software together to deliver on a specific use case.
Awesome. Yeah, and we've been working with NVIDIA on multiple blueprints over the last several months, and so it is truly for us like a really easy recipe to follow to deploy not only sort of agentic services, but then also data pipelines that can help pre-process and get data ready. And actually, I kind of wanted, first I'll mention some housekeeping things here. So if you have questions out there, there's a Q&A box. You can type your questions in. We're not going to answer them until the end, though, just to make sure that we kind of stay on track, but we will get to every question. So thanks in advance for asking them. Now, I wanted to kind of talk about how you can extract value out of data. And today we're going to be talking about the AIQ blueprint, or a reasoning blueprint. But reasoning requires that it pulls in lots of different data sources, and oftentimes people don't realize what has to happen in order for those data sources to become usable for AI. Maybe we could talk for a moment, Adil, about sort of the process of extracting and doing embeddings for data sources that enable it for AI. Maybe you had a comment or two you wanted to throw in there.
Yeah, I mean, you're hitting it on the head, right? I mean, the power of reasoning models to not just execute one given prompt, right, but to think through a chain of thoughts, a rationale, compare different potential scenarios to derive the best response. And more often than not, if not every time, right, a reasoning model or a reasoning agent needs to tap into your data corpus. And it's not enough to just be able to have connectors to those data sources. You have to extract the data from those, variety of different data sources, from PDFs to videos and, everything in between. You have to create embeddings for those data sources, so those data sources can be semantically understood, right? They could be queried with an understanding of what those data sources means, right? And so that's fundamentally what is one of the first kind of parts of the workflow to enable any reasoning agent to make use of that data, right, and rationalize through that data.
Awesome. Yeah. And actually we're gonna step through all the bits and pieces of that process in a few moments. The first thing I wanted to do though is sort of remind people what VAST is up to in this world. So we've been talking so far about blueprints, about agents, about the processing required to make data ready for AI. It all needs a place to be. It all needs a place to live. The data needs to live somewhere. It needs to be pulled from somewhere. It needs to have its embeddings stored somewhere. It needs to be able to be retrieved quickly, and there needs to be a place for processing to run. And for that, VAST has built the AI operating system, which is basically an evolution of a data platform that we started about 9 years ago to build, with the ultimate goal of helping people find better uses for their data and really be able to derive the most insight possible. There's a lot of pieces, and I'm not going to explain every single one in detail, but in essence, VAST offers a place where you can store data. You can store not only the unstructured data, which comes in the form of pictures, videos, files, but also structured data in the form of transactional history and database records. And the intent is to make it available for processing. And nowadays, AI is sort of the focus for many people for agentic processing. And so we tied all of this together, and it really gives us the ability to deploy things like NVIDIA blueprints in a relatively easy fashion. I don't know if you wanted to comment at all, Adel, so far on your experience interacting with VAST, but here's your chance.
I mean, it feels like a lifetime ago, but when I really think back to it, it was probably 3 weeks ago that Andy and I met or started talking for real, right? And this was in prep for a keynote that we had in Taipei. And we wanted to show the world, right? What happens when you marry the AI data platform, right, of the future, the platform that allows enterprises to query, understand data, build the agents on top of, make use of all the knowledge base that has to remain behind the enterprise, right, network, behind that corpus. And we started collaborating 3 weeks ago, and we'll go through that storyline of what it took for us to, frankly, build. Right, and I can't say they're VAST's first agents, but one of kind of the principles I always use is, if it's valuable for me, chances are it'll be valuable for others. And so more often than not, when new technologies come about or we derive new technologies, I look at how can they make my personal day better? How do they make my life, that work, more productive? And I think through that collaboration, Andy and I quickly reasoned through a couple of use cases, right, to show the world just how, when marrying NVIDIA's full stack acceleration, so using our microservices, right, that are that run best on our platform, right, in conjunction with VAST. It took us about a couple weeks to come together and pull this off, and pretty stoked what we're going to show now.
Yeah, definitely. And one of the aspects of this collaboration with NVIDIA, especially the lead up to some of these big events, right? So we have obviously the Computex conference in Taipei, where Jensen, your CEO, was able to present an agent that we worked on together as part of his keynote, which is pretty exciting for all of us. And it really gave us a chance to sit down and think about, well, how would we really collaborate with NVIDIA to be able to offer this to people in a much easier to package way? And so it gave us a good chance for our engineering teams to sort of put our heads together and figure out the right way to approach it. And one of the outcomes of it was an acceleration in the development path of something that we had already started working on, but it's, there's no better time than right before there's a big keynote to come together and build some things that may have been put to the side at first. So one of the aspects of the VAST data platform is that we wanted to showcase was the fact that we're making it easy, and we don't want it to be something where people who are trying to get AI started for the first time, that they have to be intimidated by a lot of things that they don't understand yet. So we try to make things as simple as possible. And again, I won't explain all this detail. We have some other demos that are online that'll go through all of these bits and pieces. But ultimately, making it easy was a very important part of it. And then when we thought about the use case, so when Adel and I and several other members of our various teams were talking, we wanted to come up with a use case to showcase these technologies in a way that really resonated with us, because honestly, it's a lot of times easier and more effective to be able to work on a use case that you're very familiar with. I don't want to go and work on a use case for one of my clients and I don't know it well enough. I'd rather work on one that I understand. So the one that we came up with actually is near and dear to my heart, which is VAST has a lot of people in the organization that wear the hat of sales. I wear a different hat. My hat's cooler than theirs. But the what I find is that oftentimes we have sales, executives who join, and it's difficult for them to get started without doing a lot of research and finding a lot of information in lots of different places. And this is pretty common across many sort of sales-driven industries, but it's actually a common thread even with other personas, people who are doing research and who are trying to understand a lot of information very quickly. That's a very common use case that we're finding, and so this one was easy for us to come up with. But Adil, maybe if you wanted to comment a little bit on sort of the choice and use case that we made, and your thoughts on it.
No, I mean, you're hitting it on the head, right? It wasn't, hey, we're not building a demo for the sake of building a demo. And to your point of, we explored, hey, we have plenty of other enterprises and customers that we collectively work with, but how do we show something real, something authentic without exposing their data? So then we looked internally, right? To Andy's point, we looked internally. How do we help, right? How's Andy helping the rest of his sellers, especially new sellers that come into regions, right? I heard your CEO, you called that our CEO, so I'm going to call out yours. I heard your CEO talk about a 5x growth, right, for VAST over the last year. And so I'm sure you guys are expanding your sales force. And so more often than not, you have either new sellers in a territory or a reconfiguration of sellers to maximize, right, all the crazy demand that you guys have. And so it was a sales research agent, right, a sales research agent that taps into all of VAST's internal and external systems. And so the use case was something that I think every enterprise can relate to. I can certainly relate to it, right? From being at Nvidia, everybody's got something to sell, and really understanding your territory, and that's not just a function of understanding your CRM databases, but it's also understanding some of the external factors that are going on, right? And so being able to tap into web searches to understand the latest and greatest in the region. What are specific climates that are impacting certain industries, et cetera. So it was about helping sellers get more acclimated with their respective region, know where to focus, and kind of take that grunt work away from having to go into CRMs, do external web searches, understand for relevant customer testimonials. And so with the blueprints, with your agent builder interface, right? I think who was it? One of your engineers was saying, "Hey, it took me just a couple 3 days to get this stood up for the first internal POC."
Yeah. He's also a beast when it comes to getting things done quickly, but it was a testament to the blueprint's ability to be deployed, as well as the simplicity of everything. And so, I think that, and for those of you out there that are not salespeople, which I'm actually not a salesperson, I probably spend a lot of my time trying to do research on all kinds of topics, and it's difficult, right? I use lots of different tools, and I probably have, a Slack window open with 30 different people asking them questions all day long, and it's not the most efficient mechanism. And so as we try to use AI every day within VAST internally, we started to build these tools, and this really gave us a reason to come together and build a more cohesive way for at least one segment of our team, which is the selling team, to be more effective. But I actually talked with the client a few weeks ago. They're more in the sort of chip design space, and they say that a lot of times the senior engineers at chip designers spend a lot of their time onboarding new people and having to dump all of their knowledge into these new people's heads before those new people can become effective. And it's a huge time sink for the senior engineers to do. Now they like to do it because they like to teach people, but that's months of time that's spent doing that kind of thing, when you could really give a little kickstart to a lot of the onboarding engineers and developers by giving them a way to be able to find out all of that information that's been packed away in different places for so long, and give it a way to come up with a plan. So that's how I kind of think about it. We did it from a sales perspective, but it could really apply to lots of different sort of job descriptions for sure. Okay, why don't we get into a little bit about what the blueprint looks like? Now, NVIDIA has a number of blueprints that you can find online. If you do a search for AIQ blueprints, you can find this on NVIDIA's website, and you'll be able to see the specifics, including all the models, model cards, and all the bits and pieces associated with it. Now, there are lots of ways you can deploy these things, but ultimately we've been very collaborative with NVIDIA in coming up with how we deploy these kinds of services. And we think we have a way to make these recipes really simple for customers to not only deploy but also maintain and refine over time. I could explain every piece of this, but maybe from a high level, I'll explain the parts that have VAST in them, and maybe Adel, you can explain the parts that are your parts of it, and I'll just explain a few pieces. So the first thing is I'm going to start on the very bottom where it says data store, and data store is storing data. It's not that surprising, right? But it's storing all the unstructured files, objects, extractions from database records, extractions from other data sources. All of those things have to go somewhere, and that's what we call the data store. Now, we also need to store structured data. So not only are we storing data that might come out of a data warehouse or data lake, but also data that would go into transactional systems as well as into vector stores. So we'll explain vector stores in a moment, but just know that if there's data that needs to be stored somewhere, we have a place for it. And then up above where it says data engine, that's really the framework and orchestration layer where computation and AI processing can run. So if you have everything at the bottom being stored somehow, you need a way to run it. And really the data engine is a mechanism to allow all of these different pieces to operate in concert. And so it has direct access to all the data that's in the data store and in the database, which reduces latency significantly and also makes it much simpler to deploy. There's only really one platform you need to deploy. You don't need to go deploy all these different services and pieces everywhere. And then ultimately, though, a lot of these bits and pieces, we didn't develop, right? So, Adel, maybe you could talk a little bit about the pipeline that you see here and sort of how it relates to what NVIDIA has done and how you see people sort of starting to deploy things like this.
Yeah, this is a fantastic representation of a blueprint actually integrated into your platform, right? And so kind of unpeeling this a bit, what each green box, if you will, represents is a microservice, right? It is a microservice that we've optimized to run great on accelerated computing, right? To Andy's point earlier, the data engine is where you're applying a lot of that computation, right? So bringing full stack acceleration, right, to be able to execute on these different pieces. And so the blueprint first comprises of an extraction and embedding pipeline. What extraction does is, to Andy's point, right, you see the arrow pointing up from the data stores. What we're doing is we're extracting from these different modalities of data sources, right? Be it PDFs that are content rich, that have tables, that have charts, that have infographics, right? Be it videos, being able to extract that data so that then, right, we're able to create the embedding, a vector representation of what that data represents so that it can be semantically searched, so it can be understood the same way a human would understand it. And so sometimes you're doing that in real time. More often than not, you're doing this all the time because it's not just, you're creating semantic understanding for that data, but that data is continuously being updated. That data is continuously changing. New data types are being added. So it is it's perfect for it to reside in the data engine. So because that data is continuously being extracted, it's continuously being chunked, embedded, right, and being indexed and stored in the vector data store. Now that we have a semantic understanding, if you will, right, or semantic representation of all the different data sources, right, stored inside the databases, we use a reasoning model, and we can get more into that. But we have a reasoning model from our Llama Nemotron family of models that we've distilled, which means we've made it more efficient, right? We've retrained it, we've fine-tuned it, we've post-trained it, which means we've added additional capabilities to that model. So we created reasoning data sets, retrained those models. We've also applied some alignment to that model, so human in the loop, right, to verify the output of that model, make it a fantastic model. And so the Llama Nemotron model acts as the interface, the plan generator, if you will, to any user query that comes in. defines a plan, and as it goes through and starts executing that plan, it is able to tap into now, right, your database that has the semantic representation of all those data sources, right, and be able to deliver on very specific outcomes. And so what you see here is different microservices that make up the IQ blueprint, and this is just VAST implementing them inside their data platform.
Awesome. Thanks for the detailed explanation of all of that. And why don't we step through it from the user standpoint, right? So I think one of the things that we wanted to make sure we did when we were building this is first we had to make sure that all the infrastructure was set, that we had sort of identified all the components that we needed to use and had done enough sort of due diligence on learning more about how the models worked and how the embedding processing needed to look so that we knew that everything was going to work. But then we wanted to make a good user experience. And so I'll show you a little preview of that at the very end. But first, let's just step through what's going on in this pipeline. And so, essentially, we start out with the user. It could be me, it could be you, it could be anybody who's wanting to do some research on a topic. And the first thing that happens is they send in a prompt. Not so dissimilar if when you use one of the AI services that you might have used with other providers, you send in a prompt. And the first thing that happens is the reasoning model has to take a look at what that prompt was and generate some kind of a plan for what's going to happen. And this is different than what we've seen in the past with sort of, we'll call them RAG-based pipelines, in the sense that the inbound prompt is actually turned into a plan. It's you don't just take the bare prompt and perform RAG against a bunch of documents. There really has to be some deep thought going into it. And maybe Adel, you could talk a little bit about that process and sort of when you guys were designing the AIQ blueprint, how you were thinking about this.
Yeah, I mean, fundamental to defining that plan is that reasoning model that you and I are talking about right now and that we're showing, right? Because your prompt can be very pointed, but it's going to take your prompt, it's going to decompose that prompt, right? It's going to generate a plan around that prompt to think about, what are some of the data sources I need to go to be able to answer the prompt correctly or effectively? Do I have access to these different data sources? I wonder if I can't find specifics to the prompt they've asked it, right? Should I be going out to the web and searching for some additional queries? And so the first step is it generates a plan that also factors in the different data sources that it's got to tap into, right? And the model is almost, you see it talking to yourself, right? It's almost like a human being trying to reason through a chain of different thoughts, right? Well, I should, look at RAG first. Let me look inside my data platform to see if the data sources are there. Well, and if they're not there, I should consider looking at the web. And so it starts going into this loop, right, of putting together a plan. And more often than not, it will go back and self-reflect on that plan. Hey, did I put together the best ideal path? Should I have considered alternatives over here, right? And so you see the model talking through itself. It convinces itself and hopefully the user, right? We give the user that option to say, hey, this is the plan the model came up with to be able to answer, right, your specific prompt, your specific query. Are you aligned with that plan, right? And so you're able to then go in and inspect that plan. In fact, you're able to go and adjust that plan if need be, right? More often than not, I don't need to do that anymore because we've, through that process at least, we've trained, our agents to kind of know my preferences. But you have those options, right, before it goes and starts executing on that plan.
Awesome. Yeah, thanks for that. And sorry for hitting the slide button. I got trigger happy there. So, as Adel mentioned earlier, first the plan gets built, and then it needs to go and consult data sources. If it can't come up with what the user's asking for on its own, it needs to go and consult data sources. That's it's very similar in that way to a RAG system, but it doesn't really stop there, right? First, it has to go and pull in information. And one of the good things that was kind of given to us, we'll say, by our friends at Anthropic was the concept of Model Context Protocol, or MCP, which actually makes it really easy for us to go and create connectors for all these different data sources. And these are some examples of ones that we use within VAST to be able to go and do our jobs every day. And I personally probably spend more time in Slack than I spend in email or in anything else. But ultimately, there's lots of places to find information. And as that information is pulled from all these sources, it's pulled through that processing that Adel was mentioned earlier. Basically, going and performing extraction on data and then converting it into something that can be easily searched and found later, right? I always kind of align the concept of vector embeddings to the concept of turning words into numbers, right? So, when performing some kind of similarity search against a vector store, it's a lot faster to do that if you have a numerical representations of all that information, and that requires some processing that happens up front. I don't know if you wanted to add anything to that, Adel, before I move on.
No, I think you characterized it perfectly, right? And there's a reason why that layer, that extraction, that embedding creation exists on the accelerated computing layer, right? Your data engine, if you will. It is computationally intensive, and it is something you're doing continuously, right? Again, as we talked through, the data is always coming. So making sure you have the best efficiencies when you're doing that, especially because you're going to be repeating those processes, right, as additional data comes in or data changes, is important. And so we talk about the value of our blueprints as a whole, but even when you look at the microservices individually, right, they all bring in value in by themselves. And so when we talk about being able to do extraction embeddings, we pride ourselves are being able to do this with the most efficient throughput as possible, right? And so doing this without NVIDIA's software, right, versus doing it with the blueprints, we see a 15x improvements in the throughput of creating those embeddings for the data for it to be continuously vectorized.
Wow, that's awesome. Yeah, actually, it's funny, like we've loaded these embedding models and done embedding an extraction for the last several months, not just leading up to this, using some of those models, using the NV ingest pipelines. And I guess I just took for granted how fast it was. I wasn't comparing it against another method of doing so. So it's good to know.
You're welcome.
Now,
You're welcome.
yeah, anytime, no problem. Now, so okay, so we've done some embeddings. We have them in a vector store, and so now we have a semantic understanding of this data in a way that can then be searched upon later. And so all that information gets pulled into these places, and then the reasoning model then, well, it has to think about what it's found, right? It goes in, it says, okay, I need to find all this information, I need to collect it together. But on its own, that's not enough, right? Knowing how much a particular salesperson sold last year, and knowing how many support tickets are open for this customer, and knowing what the customer's emails have been looking like from a sentiment standpoint, those are nice data points on their own. But even just imagine you as a human are trying to think about how to tie all this information together and come up with a plan or a summary. This is really an important stage of making sure that the data that's coming in isn't just useful data on its own, but that we can turn it into something more useful by combining it. Maybe you have a way that you like to look at it, Adel.
Yeah, I mean, I think, right, it generates an outline, right? It starts by generating that outline, the couple of steps we spoke about earlier. And then it looks at, okay, double checks, is this the right outline? You know what, I'm going to go execute on this. It starts going in and starts extracting, right, from those respective data sources, and starts populating that outline. You literally see it being populated as being generated. But once it creates that outline, right, it starts, you have the word reflect highlighted over there. It literally starts doing self-reflection, like you checking your own work or you checking your kids' work, right? It goes through it. Hey, does this make sense? Did I find all the data sources that I was looking for? Oh, is there a different method that I should have considered? Right. So you see the model. You can again control this, the number of times you want to self-reflect, because there's always that trade-off, right? There's always that trade-off between how often you want that model to recheck its work, right, versus when you get the final report, versus when you get the final outcome. But I think one important part, Andy, as part of this kind of self-reflection of, hey, right, am I able to go and execute on the tasks that I've defined through my outline, including sourcing data from relevant data sources? One of the things that always comes up in my enterprise conversations is this notion of access control, right?
Mm-hmm.
You've now vectorized, you've created a semantic understanding of your entire corpus, and it resides in this awesome knowledge base in your data platform. How do we ensure that as part of these agents, as they do self-reflection or otherwise, right, as they're executing, they are not tapping to data sources that frankly that particular user is not supposed to have access to?
Yeah, and that was actually one of the things that we've spent a lot of energy on about 6 to 8 months ago when we were originally developing the Insight Engine, which was our first sort of foray into doing RAG on the platform itself. And the good news is that we've been building the scaffolding for this all along without really even thinking about it, because we had to accomplish a different need. So if we go back in time a little bit, VAST was focusing mostly on what we call the data store, which is storing data. But that data can be stored in both file and object form. It can be accessed over multiple protocols simultaneously. And we needed to come up with a unified way of accessing that data. And so we came up with a policy model that looks very similar to what you might see within AWS with their IAM policies. But we had to obviously extend it so that it applied not only to access of S3 data and buckets, but also to files that are being accessed over NFS and the Windows File Sharing Protocol, SMB. And so we had to extend our implementation of those protocols, but still make it compatible with end user clients, and then create a way for administrators and people who are building out architectures to ensure that they could have granular control over what everyone had access to without having to go and stamp permissions all the way down on everything. So we created a policy model. It's very easy to use. And there's some examples, I think, on one of our other sort of videos that we've made before of what those policies look like. But they govern access to all data on the platform. Now, incidentally, we also introduced a database a couple of years ago, and we needed a way to govern access to that. And so instead of creating a new way of doing it, we applied the same policy model where you effectively can specify a database table as effectively a bucket, a prefix, and then potentially column and row level security is another sort of downstream prefix in front of or at the end of that. And so that way you can decide who has access to data that's either in unstructured stores or in structured stores without having to go and change the type of policies you're implementing. Now, how does this really impact us when we're doing some kind of AI, like basic RAG, or in this case, an agentic research system? Well, the way that it works is whenever a piece of data is embedded. So let's say you take a document and it gets split into pieces and turned into embeddings. But as those embeddings are inserted into the vector store, they're labeled based on the policy that governed the data that they were based on. So if, let's say, you had access to all the HR data within NVIDIA, then there would be a policy associated with that data, and that same policy would apply to the embeddings that were derived when running through that embedding process. And so when, let's say, Adel goes and searches for something, his identity passes through when he's performing the search, and that identity is carried through each stage of searching. So if we have to retrieve database records, that policy checks to see if Adel has access to those database records. If we have to pull pieces of documents in order to formulate a response, that same process will go and check and see if he has access to those documents. And the same is true for database records, vector store, entries, and files and objects. So it's really easy for us to do it. And really the only reason is because we had to start with a framework to allow for lots of different access patterns to the same data, but still make it really easy for people to sort of control that access. So it's sort of fortunate that we were able to do so in a way that was extensible into the next thing that we're doing, which is all of this agentic processing.
That's awesome, Andy. So I think what you're saying is, right, no matter whether it's unstructured data or more traditional data, the access controls that are in place are seen through by the agent. And so I love to compare agents to companions, right? Digital workers that help us out. And so just like when you're onboarding a digital worker, right? Excuse me, just when you're onboarding a real employee, right? You teach them in your norms and VIs, and there are some things they have access to and some things that they don't have access to. And it sounds like it's kind of something similar here, right? When you're onboarding your agent, you're able to carry through what that particular agent has access to, whether that's through attributes or role-based. It sounds like that data provenance is maintained throughout.
Definitely. And it was important for us as we rolled out into lots of what we consider to be enterprise customers who have relatively rigid controls in place for everything else. So why would it be different for an agentic AI system? It has to conform to that as well.
Makes total sense.
Now, as the data is then reflected upon within the reasoning model, it then needs to go and, well, let's talk about re-ranking for a minute. Like, why don't you describe re-ranking for the people on the call that maybe don't know what it means?
Well, I mean, to layman, right? Again, we have a microservice that's a re-ranker, and every time you introduce a microservice to the pipeline, right, you're always evaluating potential latency against accuracy. And what re-ranking does is, when you're doing the extraction, and again, kind of going back to your notion earlier, Andy, of hey, you're getting a numerical representation of the numbers, right? So that then you can do better similarity searches as opposed to direct hits. Well, it will come up with a suggestion of what it thinks are the right responses or the most accurate responses. Because when you're talking about similarity searches, right, right, versus an actual meaningful understanding of the data sets, some of that can be subjective. And so what the re-ranking does is it extracts the right chunks or the right representations from the vector data stores, kind of pairs them up against each other. The reasoning model, again, because it's a reasoning model, right? It's got its outline. It's able to see kind of the recommendations that are provided, and that's not a one-time loop, right? That's not a one-time loop. The reasoning model could follow through on subsequent prompts and further iterate on refining that response. And so what it does is it just ultimately it's another microservice that is part of the pipeline that ultimately translates to the potentially the best and most accurate and most relevant response, right? That's grounded in the data sources that you're giving your agent access to.
Awesome. Thanks for that explanation. I think that it's underestimated oftentimes. Well, maybe it's underestimated by some. How much effort goes into making sure that the results are as accurate as possible. And if you don't deploy services like re-rankers and have a way to make sure that what you're doing is the most accurate possible, you're going to wind up with users who don't enjoy the services that you deploy, right? They're going to just assume that AI isn't good enough for them, and they're going to move on to something else and do it the old way. And so I think it's really important to think through all of these things and not give up when the responses aren't good enough. There are ways to refine. There are things to make ways to make things better. And speaking of refinement, sort of once once re-ranking has occurred, once all of the thought has gone in from the reasoning model side, it then has something that it can generate. But typically, the reasoning model itself isn't the thing that is doing the final generation of what goes out to the user. And so maybe, Ali, you could explain the purpose of having yet another model in this pipeline.
Right, and I'm glad you brought that up. Reasoning models are fantastic, right? And kind of what I was alluding to earlier is reasoning models think. It's almost like they talk to themselves. They're doing token generation, right? You see them thinking through. And so that token generation is computational heavy, right? It makes sense when you're defining a plan, right? That you need to iterate through and think through. It makes sense when you're doing some self-reflection on the plan, right? But once you've extracted and sourced the relevant data sources, once you have your plan outlined, defined, the actual writing of the plan, the generation of any report, right? If you don't need a reasoning model for that. Why use something that, right, is more computational heavy? And so again, we're always thinking about full stack acceleration. We're always thinking about optimizing our blueprints to be as efficient as possible, right? Because if tokens are the new currency, right, you want to be able to drop your cost of creating those tokens as much as possible. And so just because reasoning models are great in this particular step of, hey, go write the report based on this outline and these data sources, these models are fantastic. Llama Nemotron, Llama 3.1 70B models, fantastic at just writing those reports. And so when not needed, we use just LLMs to generate reports, and then we can use the reasoning model to, frankly, either judge or reflect on the outline, right? Kind of do a second pass. And so that's why we introduced another model. We saw that it made the pipeline more efficient at running without dropping any of the underlying accuracy or the quality of the reports that are ultimately generated.
That's awesome. Yeah, I mean, I think the other thing I've noticed over time is that obviously the cost of GPUs is it's an expense that people are getting used to, and the cost efficiency of deploying platform services, pipelines, but ultimately how you use the GPUs is as important as ever, right? Coming up with ways to reduce the cost, but it also means that you can increase potentially the speed. A lot of these reasoning models are slower it's not just that they have to generate more tokens, they take longer to do it. And so I think that it helps for, people to understand that, when we have a model that's fully capable of doing that final leg of generating a report or a summary, that it's better to use one that can do a good enough job that makes an accurate report, but to spend as little cycles on it as possible to make it so it's less expensive, but then also to make it so that the user gets their response as quickly as possible.
That's
So
right.
it's
That's
great to
right.
see it.
I mean, these systems are, all about token generation, right? And again, if tokens translate to intelligence, intelligence is how you get your competitive advantage, right? You want to be able to generate those tokens, as you said, as that intelligence as efficiently as possible. Speed plays a role, right? And then we're always making sure we're balancing doing this as efficiently and as fast as possible whilst maintaining accuracy, right? And I think an AI data platform is perfect for that.
Awesome. And so, not to give you guys the whole demo that we did, or that actually Jensen did on stage at Computex, but we effectively, I forgot the last part. So anytime you have a report, you have to generate it and send it to somebody, right? And so the whole point of this entire process here was for a salesperson, in this case, to ask a question or to ask for a specific plan to be generated, and then for this entire pipeline to go and do the work on that person's behalf to go get it done. And ultimately, what they want is a report and a list of actions that they can describe what they're going to do next. Now, you could start to build more agents on top of this. You could imagine that this could just be the input for the next agent, which would actually perform some of those actions, like sending emails to prospects or creating sales proposals or diagrams and charts for customers to go and look at. We didn't get that far in our demo setup because, well, we had a certain amount of time and we wanted to make sure that we did a good job with what we did. But one of the great things that I mentioned earlier, because of sort of our adoption of MCP within our services layer, is that we could take this whole pipeline once it's deployed on VAST and expose that whole pipeline as an MCP tool, so that another agent could go and use it to be able to pull information out and then do the next step in the chain. So
I'm actually really glad that you
go ahead.
brought it up, Andy, because I think there's one kind of misconception in the world, which is you have one Uber agent that does it all, right? And I think without going too detailed, right? But any kind of one of those workflows can be broken up to multiple different workflows. We talked about on the ability to do deep research on my corpus of data for a sales use case, right? We talk about doing web search here, but you could very much have an agent that specializes in doing web search. To your point earlier, right? More often than not, you're breaking down your workflow into multiple agents that are collaborating together. I think for our demo, one of the pieces we tapped into, again, using the IQ blueprint, we published a video search and summarization blueprint. Gosh, feels like a lifetime ago, but that was GTC, so less than a couple of months ago, right? Mm-hmm. And you guys were one of the first to onboard it into your platform, integrate it into your platform. And so as part of this workflow that we have here, which we don't really show, right, because we're telling stories, is at one point, part of the data sourcing includes going and understanding different customer testimonials that you guys might have published that are relevant to the new sellers, right, region and domain. And so, right, and that's part of the value prop that IQ delivers. It's an AI query engine that allows you to build your agent platform, build multiple agents. We're all on board for MCP, right? With our toolkit. To your point, you can enroll any new data source or any new agent, right, and be able to leverage it as part of your bigger team, right, your team of agents. And so, just having that, it's not a single agent. We're going to have multiple agents collaborating, not just with us, but collaborating amongst each other.
Yeah, no, it's really exciting. And basically when we started to look at this whole thing, we said, well, what can we do that'll help our own jobs, right? Because that was the question that we within VAST had to ask ourselves, because we wanted to showcase something that made sense to us, and we wanted to make sure that we could use it when we were done. We didn't just want to build something for the sake of building it. We wanted something that we could use, because otherwise you spent some time on just a bunch of pretty pictures. Now, I guess, ultimately, there's going to be a lot of things that people want to build out of this. I do know that we have a few minutes left to answer some questions. And it looks like there's probably two of them that I can pull off, but maybe the first one at the very bottom there is one that you could pull off. Do you see that one, Adel?
I think so. Go for it. Start it. I think mine
Yeah.
might
So
be
the
in.
question, yeah, the question is, I'm confused by referring to a collection of vectors as a quote semantic unquote understanding. Can you elaborate?
Can you hear me?
Yes.
Okay. Was that? Oh, you want me to take that one?
Yeah, that was the one. I mean, I can take it, but
Yeah, yeah.
the other two. Yeah, go ahead. Sorry.
No, yeah, no. The point I was making there is once you're able to when you extract the data from your different data sources, PDFs, videos, infographics, etc., and then you create embeddings, vector embeddings that are representative of what those data sources are, then you're able to query that data right in a semantic query type of right. You can understand that data as opposed to just looking for direct word matches, right? And so an example, I was telling my wife about the other day. She's like, well, what does that mean? I'm like, well, somebody could say it's raining cats and dogs, right? If you're not well versed in the understanding of what that expression means, right, you're always going to correlate it's raining cats and dogs with like animals dropping, right? When really what you're trying to say is that it's raining super hard outside. And so the point that we're making over there is once you extract, you embed that data and you store it in the vector data store inside of VAST's platform, you're able to derive, understand that data as a whole through semantic searches and understanding.
Awesome. Thanks for that. The other two, I feel like I'm gonna probably take. So the next one was the data engine is running on an NVL72 or something similar. And the answer actually, so when we were building this out in our own environment, right? Because we have a lab and we use it for a lot of different things, and we have a DGX in that lab that's running actually with older cards right now. We have a DGX A100 that we set aside for this. But the good news is that most of the models are able to run pretty well just on that host. Obviously, the more GPU memory you have, the better. But if we want to go back and take a look at the actual models that were used, right? So we have a 70B Llama 3.170B, right, which requires about 140 gigabytes of memory altogether, something like that. And then we have a Llama Nematron model, and I forget the size of it, but the amount of infrastructure that we had to deploy to run this pipeline was pretty minimal. It wasn't crazy. That said, like it depends on the concurrency and scale that you need to get to. There isn't a hard and set rule here. You might have a lot of data to go and process, and that would probably lead you down the path of wanting to have more GPU horsepower. Or if you're just looking at starting from where you are right now and just processing new data, it's probably enough to start with something small. I would say always to go and become, start where you feel like you have comfort and then move from there. I guess one question maybe for you, Adel, is as you see people sort of building out these pipelines, where do they start? Are they starting big or are they starting small?
I mean, look, so NVL72, that's part of our Grace Blackwell infrastructure. Grace Blackwell is ARM-based, and so you got to think through the entire software ecosystem as you decide kind of the infrastructure you want to deploy this on. And so when you're talking about A100s or H100s or even like our x86 Blackwell platforms, all of these microservices run on those platforms, right? And that's the CUDA promise. But to your point earlier, I'm always a fan of starting small, demonstrating one use case, understanding the pitfalls there, making sure you have the guardrails in place, making sure you have your ACLs right maintained before scaling into more complex use cases. So we're always about starting small, right, and then demonstrating success before scaling on to others.
Awesome.
And yeah, we always strive and make sure that as new infrastructure comes to market, right, our blueprints are optimized for those platforms, and you can bet that the optimizations that we have on any given day continue to improve over time. And so that's kind of the part of the value proposition, which is right. We containerize all of our microservices, right? I mean, a blueprint's a collection of different microservices, and we publish a lot of these microservices on a recurrent basis, on a regular frequency, just because just through software optimizations alone, folks can get additional performance benefits, whether that's throughput, accuracy increases, et cetera. And so part of betting on our platform is that just through software optimizations alone, you're going to continue to see hardware, performance benefits on the same
Awesome.
infrastructure.
Yeah, thanks. Yeah, that's great to know. Next one, I'm probably going to take also. Question was, you have the NVIDIA microservices inside a box labeled VAST Data Engine. Does this imply that they are running on C nodes, which is a VAST data concept? And is VAST applying the NVIDIA microservices as an offering? We have large GPU clusters. Presumably, this all works similarly if we run the compute on our existing clusters. So the answer is that it's pretty flexible. So the fact that it's inside the data engine really is kind of labeling that we're performing orchestration. It doesn't necessarily mean that the compute itself is running directly on the hardware that is directly associated with VAST. So actually in the setup that we did within our own environment, we had the VAST data platform acting as effectively a control plane to fire off microservices that were running in an external Kubernetes cluster. In part because sort of that's the current version of our own software, of our platform software, is that's how we get all these things to work, right? So what's embedded in a platform are obviously files, objects, database tables, and the ability for when new events happen, we can generate Kafka messages. Basically, we have our own event broker that's built onto the platform that can both send and receive messages, and that becomes the basis for functions that will run. In this case, we're using Knative functions running in an external Kubernetes cluster. But as we release new software over the next several months, more and more of that logic will be embedded. Now, the GPUs themselves are external to the VAST cluster. In fact, in this case, they're not even running inside of a Kubernetes context. We just have them running in bare Docker containers on a DGX and on a few other GPU servers that we have. Basically, the way that we interface that with our platform, with the VAST platform, is we expose the endpoints of the particular models as well as the model identifiers as environment variables into the different components of the pipeline, so they know where to send these things to. And that's kind of the design goal, for the next period of time, which is when you define a service, either using our low-code UI or using the sort of JSON or YAML representation of it, you're going to be defining the models you want to use and the endpoints where they live. And the endpoints don't even need to necessarily be inside your data center. They could be in the cloud. They could be in NVIDIA's cloud and NGC. So there's a lot of flexibility on how to put it together. So if you have a GPU cluster, run all your models there. And as long as you can expose those models using a model serving framework, and it could be any sort of OpenAI compatible API or Ollama compatible API, then everything will work just fine. So the answer is no, we're not running all of the models on the C nodes themselves. There may be some future plans associated with that, but for now, it makes more sense to run them on the systems that have been deployed explicitly for GPU-based services. The next question
we have
have
a question about Llama reasoning model, right? The Llama Nemotron reasoning family. Yeah. And kind of like I think that's a collective response for both of us. So thank you for the question. So just to be clear, right? What we did with Llama Nemotron was when I was talking about post training, it was about bringing in some of the reasoning capabilities into that model, right? For specific tasks. So making sure that model's good at reasoning in certain domains, right? That's the fine tuning I was talking about. MCP and the kind of the client server, setup that MCP enables, right? MCP is the protocol. It's the standard for that communication. And so, the IQ blueprint, which has Llama Nemotron reasoning models, supports, right, tool calling into any, utilizing MCP. And so I guess, Andy, the flip side of that question is, if I'm using the VAST, data platform, or your AI operating system today, if somebody comes in and sees the reasoning model already installed there, are you guys making connectors to data sources available via the MCP protocol that users can just pick up and tap into?
Yeah, so there's some basic things, like for example, on the VAST side of things, every database table that's contained on a VAST cluster, every Kafka topic, every bucket, meaning like an S3 bucket style sort of interface, those are all available as MCP tools to other services, right? So that's our own stuff. In terms of building connectors for external sources, And a lot of times these external sources already have an MCP available, right? Like, so we don't necessarily have to build anything there. We just have to integrate it. But anything that we build on our platform, we will expose as an MCP tool. And even including this entire pipeline can on its own be an MCP tool. So, it's sort of it's cascading MCP on top of MCP, but effectively you end up in a way where the agents can get access to data that they need without having to go and write a lot of extra code to do it. There are actually probably more questions to answer than we have time for, but I can take another stab at another one. One question was the fact that we're using MCP. Would we say that MCP has won as the agentic protocol? I'm not going to say yes, but I will say that Mistral just released some things today that directly integrate with MCP. And Anthropic, obviously, they created it. OpenAI and a lot of the other model providers, as well as the services that they're associated with, have all sort of adopted that standard. I think for us, it was kind of a no-brainer. If there's another protocol that becomes prevalent, we could definitely look at it. I don't know, Adel, if you guys have anything on that side of things.
No, I think, look, right, with agentic AI, right, like to me, the how I've been rationalizing MCP and these protocols, like a REST API. REST is kind of the de facto for how we get, microservices to communicate one another. I think it's too early to call out any winners. In fact, I would say we always want to embrace the ecosystem and we want to contribute to that ecosystem. We see momentum with MCP. We see, right, A2A emerge, right, as a agent-to-agent communication like protocols. So there are a lot of standards and protocols emerging for this new world that we're stepping into. We're gonna embrace them where they make sense, right? And certainly MCP is one that's making our developers' lives easier. Oh yeah, there's an MCP server for that. I don't have to worry about creating the connector. So it gives me that protocol, that standard for connecting the large language model, a reasoning model or otherwise, right, to a tool. And that tool could be a database. That tool could be a different agent. That tool could be a calculator or a map of some sort, right? Or it could be a pipeline of agents. And so that's what that enables.
Awesome. Thank you for that. And then, the next question was whether if the code for this demo is available. And right at this point in time, the code is not in a state where I'd want to share it with the world, right? We got it working internally. We're working it against our own data. We're having our own internal people test it and get value out of it. We're not ready for exposing it to the world. But what I will say is that later on this year, when we fully sort of release a lot of software that supports all of this, we'll also be releasing pieces of example pipeline code, leveraging NVIDIA's blueprints, as well as doing other things that may not even have anything to do with AI, right? A lot of the customers that we have very basic data pipelines that don't even require GPUs at all. It might be converting a file from one format to another. Like, for example, in video encoding or even video splitting is a very common use case that we see across our media and entertainment customers. Those are really basic functions. And so we're starting to write these little bits of code and publish them, but we haven't unleashed it yet because we haven't finalized all the pieces in the platform to do it, right? So the version of the software that we ran this demo on, the version of VAST software, is not currently out to the public yet, so we can't release the things that are built on top of it just yet. But we will be releasing a lot of these pieces of code over time.
But Andy, if somebody wanted to get started, right? I think it makes sense that you're not releasing the sales agent that you guys built for your specific, your sellers. But if somebody was to get started, right, and kind of they've got, Gen AI developers, right, part of their organization, or they just want to think around, how can they get started? Because the blueprint does exist, right, and your platform is thriving in the market.
Yeah, no, I appreciate you you mentioning that. We have a bunch of talented engineers who engage directly with customers on these projects, and they're happy to get involved. I think what I want to make sure that people understand is that we want to deploy things that are going to be very repeatable, and so we're definitely happy to consult and come up with different ideas and show you examples of how to do things. But when we release things, we like them to be supportable in a way that we've tested it, we've checked for bugs, we've done all the basic things to make sure that they work for people, as opposed to releasing stuff that we're still tinkering with. So we will start to release these things, and we're happy to go and talk through use cases with people and identify some of the right approaches, and in some cases identify which of the NVIDIA blueprints might fit the model best that you're looking for deploying. There are a couple more questions, but we are actually at the end of our time. We haven't lost the questions, and so we're going to send responses directly out to them, and I'll rely on my web team and my other teams to make sure that happens. But I'm gonna say thank you for everyone's time, and and Adil, thanks so much for joining us today. This is an awesome conversation.
Andy, appreciate you. Thank you for having me, and I feel like this is just the start of showing the world what they can do with amazing accelerated data platforms and NVIDIA AI. So looking forward to more collaboration.